is on, we're going to do those identities on page, starting on page 212.
212.
To hear you on this thing, you're gonna have to talk up real loud. It's right here.
I'm always on the.
Yeah. Do they record those too? Yeah.
Video. And everybody gets most of the answers when they watch the video.
Okay. What this is that it's to approve identities. So what we have is sine squared alpha plus tangent squared alpha equals secant. Now, what I'm going to do is I'm just going to draw a line here, and just to remind us that we don't go across the equal sign. We simply stay on one side or stay on the other and make them look alike. This is not an equation. This is approving identities.
Yeah.
So you want to make this side look like that side, or else we'll work some where you can work this one down and then eventually get them to look alike across them. Or if you can't, then they're not identities. Okay, usually you work with the most difficult side to start with. And if you look at this and then you reflect upon secant squared, one of the identities is tangent squared plus 1. And do you see that if you rearrange this thing,
sine squared plus cosine squared.
yeah, you rearrange this thing like this, and then if you join these two together, you have tangent squared alpha plus 1, and the identity there is that this is secant squared alpha. And now what you've done, we've shown, see that this and this are identical. So they're identities. So therefore, identity. That's how you do it. This is just therefore. Remember back in geometry where you put three little dots? It's a lot longer ago for me than it is for you. But when I've shown that this can be reduced to this side. Okay. So now what we'll do next, we'll look at 56. Secant alpha minus tangent alpha. This is the quantity squared equals 1 minus sine alpha 1 plus sine alpha. All right. Now, the most difficult side is this one, and what I'm going to do with it is I'm going to change it to in terms of sine and cosine. So I mean that's usually the easiest thing to do. Let me see. What? This side right here. So what I want to do then is I want secant's 1 over cosine, right?
Yeah.
Minus sine over cosine. and this is squared. Now notice that this has a common denominator, so then I can write this as 1 minus sine alpha over cosine alpha, and that's quantity squared. Now you keep looking at this thing. Do you see this thing? I can square that numerator. Like that, can't I? And then I can square this denominator. Now what I can do here, I can multiply this by 1 minus sine alpha over 1 minus sine alpha. And that would make that numerator 1 minus sine alpha, the quantity squared. So I'd have that much right. My denominator, I have 1 plus sine, 1 minus sine. That's 1. It's 1 squared minus sine squared alpha, right? A plus b times a minus b is a squared minus b squared. But now what is 1 minus sine squared?
Cosine.
Squared. Cosine squared alpha is what that, and then on my numerator is 1 minus sine alpha. And you see these two are the same. Now if I wanted to, I could go right on down here, write this next, and then go up and get back up to there. So I've shown identity, right? Therefore, all right. You just got to kind of, now notice it's, remember what we talked about? It told you to use this thing. Remember this thing it's something you can use, and then it told you to reduce it to everything to sine and cosine. So these are just tricks that you use to make it work out.
So you always put that 3 dots and identity?
Well, I'm just saying, therefore it's an identity, because that's what the instructions were. Is that no? You could just say indicate that this indicates its identity.
Oh.
Because I've taken each side and reduced them down until they're exactly the same. Notice you don't go across that equal sign.
Right.
That's why I draw that line down there to remind you. You don't go, yeah, make them identical. Okay, so we'll look at 68. Says sine theta cosine theta. Now this side is just unbelievable. Sine theta over 1 minus cosine theta.
Who thinks these things up anyway?
It's in the book. I don't know. Somebody in the book does it. The author of the book. Just think they have to make it so that it works. All right. And I would suggest that when you do this, that you draw that line to make sure that you remember not to go across it. Now, the most difficult side is this one, so let's just work on simplifying it. And what I'm going to do is I'm going to try and get common denominator in the denominator. So this is going to be sine theta. Now, can I just write this as sine minus cosine over sine? If I do this, this is what I'm going to do. So I get a common denominator.
Oh, sure.
Then I got sine minus cosine over sine. But it's just, Brad, do you see it? You see, I'm going to go common denominator. I'm just working on this to get a common denominator. So I have to multiply this by sine over sine, and then I can write this thing as sine theta minus cosine theta over sine theta. No, this is we're subtracting this one from this 1 minus this thing, and I have to get a common denominator.
So what happens with one side?
I put them together, got a common denominator. So I made this thing so that it's a common denominator to this one.
Oh, you need one. Oh, I see.
Yeah.
Got it.
All right. So now I'm going to go plus, and then I'm going to do the same thing here. I'm going to make this common denominator, but this is going to have to be multiplied by what?
Cosine.
Cosine over cosine. So now, in the numerator here, I got cosine. Cosine. I'm bringing this thing down, right? Then I got this line, and then I got cosine theta minus sine theta over cosine. Now, what I'm going to do is I'm going to take this quotient that's in the denominator, and I'm going to invert and multiply. So I'm going to, that's this thing right here, right? Then I'm going to multiply and invert this thing and multiply. Do you see what I did? Then I'm going to go plus, and then I'm going to do the same thing with this. I'm going to go cosine theta, and then I'm going to invert this thing and multiply. Cosine theta over cosine theta minus sine theta.
You're inverting the bottom.
Yeah, I'm inverting.
Yeah.
It's like 5 divided by 1/2, and I just take the 1/2 and invert it. And,
I got you.
yeah. So now, now notice that this is sine minus cosine, and this is cosine minus sine. If I take a negative sign out of this thing, put it up here, then these two denominators become the same, don't they? My numerator is going to be sine squared. But now what I'm, and then this is over sine minus cosine theta. But this, what I'm going to do is I'm going to take a -1 out of there. So it's going to be a minus cosine plus sine. Right? And then that -1 is going to come right up here and make this a minus sign. Understand what I did? So this is what I'm going to do is I'm going to go minus, and then this is going to be numerator cosine squared. And then I have this thing as sine theta minus cosine theta. And you see what I did is I did that in order so I could get this common denominator, right?
So what did the sign change though?
This changed right here because what I did is I took this and took a minus sign out, changed the sign of these, and I changed the order. And then that minus, I can take it right up there. Is that too much of a jump to do at once, or do we need to?
Okay.
We're recording it, so you can always go in and you can look at it. Now notice we have this common denominator, so we can write our numerator as sine squared theta minus cosine squared theta all over sine theta minus cosine theta. Now we should probably take a look here. You see where we're trying to go? Sine plus cosine. Well, here's the difference of squares. Do you see that difference of squares? We can factor that difference of squares into sine plus cosine, sine minus cosine, and we got something we can cancel,
yeah, I
right?
remember that.
Right? So what I can do is that numerator, you see, I can go sine theta plus cosine theta
Yeah.
times sine theta minus cosine theta. And you see, I'm almost to the point to making them look alike, right?
Mhm.
And now
That's-
this
can't
is the
do
same
that.
as that, and then what I have left is that right there.
Okay.
Sine theta plus cosine theta, and that is the same as, is up here, that, right? And therefore it's an identity.
Yeah.
Now notice what did I do? I worked with my everything to sine cosine.
Yeah.
And kept manipulating, and then keep in mind where you're trying to go. All right? It's gonna take some thinking to do this.
Yeah, I don't like thinking too much.
And I'm not giving you two, I think I'm giving you two of these things to do. So,
Good.
That's the total homework for a week?
well, I'm giving you some of the on the other ones, but on terms of these identities, I'm giving you two. And one of them is going to be fairly difficult, so. Do you follow what we're doing? And notice that back on this one, this is a little trick you got to be sure and remember that you can do. And then what you need to be doing is either working both sides down, and I worked both sides down because both these were a little bit confusing. This one, I didn't work this one down because this one was the most confusing one. And then as you got down toward the bottom, you could kind of see what you had to do with it.
It's landing out.
That was a pretty neat trick when you took one and made sign.
Oh, you mean this one?
It's an easy
Yeah.
one, but I wouldn't
Yeah.
have thought of that.
Yeah. Well,
Yeah, that's
after you
fine.
do these a few times, I mean, you sit and think about them. When you did geometry, did you ever work on a problem and then put it down and overnight let it go, and the next morning just figure it out? Yeah. Yeah. That's what I did a lot of times. I have a hard problem and I just look at it close, go to bed, wake up the next day, I could just whip it out. My mind was working on it all night long, I think. I slept okay. I just knew that the next day I'd look at it again. 74. Now, you'll be happy to know I didn't give you ones at the very bottom here because these can be really tough. So what do you think? Probably work on that right-hand side,
Yeah,
get it
I'll
kind
do-
of down into sine and cosine. So,
Definitely.
yeah.
Definitely. Holy cow, this is crazy, man.
I mean, just let's just take a look at that thing a little bit. Do you notice that you have a cosecant there and a common 2? There could be possibility that you could take a cosecant out, but then I don't know whether that really makes it, out of these two. But I don't, maybe what we're going to do is this. Cosecant is what? 1 over sine? 1 over sine squared theta minus 2, 1 over sine theta times, and this is cosine over sine, right?
Yep.
Cosine over sine, and then it's minus 1. Well, now notice these two things are really sine squared, aren't they?
Yeah. You have to change that -1 to a sine over sine.
This is 2 cosine theta over sine squared theta. See that 2 that's all multiplied across the top. Minus 1.
Oh, you just multiply. Oh, okay.
I multiplied the 2 times the 1.
Yeah.
2 times 1 times cosine.
And you made the sine squared.
And then this sine and that sine is sine squared.
Minus.
This side over here could lend itself to multiplying by 1 minus cosine, right?
Yeah.
Right? If we're working down,
Oh.
and then we could have 1 minus cosine squared in the denominator, which would be sine squared, right?
Yeah.
And then this thing squared in the numerator. You see, I'm just looking at it. Do you see do you see we got sine squared in the denominator here?
Yeah, if we multiply.
And if we multiplied this side by 1 minus cosine, 1 minus cosine, and 1 minus cosine. So that this denominator becomes 1 minus cosine squared, like this was theta. And 1 minus cosine squared is sine squared, right? Right?
Oh, yeah.
And then this one is 1 minus cosine theta, the quantity squared. So this thing here is sine squared. You see we got sine squared here. So what would maybe be advantageous to get this as sine squared over sine squared, right? So we got a common denominator there.
Yeah.
Maybe that would be good.
Nice.
I'm kind of reaching a dead end in my thinking here. What?
Yeah, change that to sine squared.
Saying when I do that, then I have 2 minus 2 cosine minus sine squared. And then I have it all over sine squared. Now, you see that this is 1 minus cosine over sine squared, isn't it? 1 minus cosine is. So we're getting close. What would happen if we change this to 1 minus cosine squared? Then we'd have the numerator all cosines, right? You see what I'm saying? Then I got cosines in the numerator. I'm going to go 2 minus 2 cosine theta minus, and in place of sine squared, I'm going to put the Pythagorean identity, 1 minus cosine.
Oh.
The process is just a little bit of experimentation to try to fudge it around and get it working. So now, you see, this is going to be a minus 1. It's going to, I think I can factor that thing. I think this thing is going to be, I think it's going to be maybe factorable in the numerator. I don't know for sure. But before I go too far, I haven't lost any signs, have I?
No.
This was in there right as a minus, wasn't it?
Yeah.
At the very beginning?
Yeah, yeah.
That was a minus, that was, and I haven't lost any signs.
Just
What's that?
7 students.
Well, no, you're with me, aren't you? You're kind of,
Yeah. Yeah, I'm with you, but if I could remember how to do it, I'll be darned.
well, you just, what am I doing? I'm just kind of saying, well, I think I'm going to try this, right?
Yeah. Just go with it.
So then this numerator is 2 minus 2 cosine theta. And then this is going to be a minus 1 plus cosine squared theta, right? So I'm going to write this in descending order. I'm going to write that as cosine squared minus 2 cosine theta. Then that's a plus 1, right?
Yep. 2 minus 1 plus. Now you're getting it down where you can split it in half. Okay. Got your square middle single.
I think this is going to be, the numerator factors into cosine theta minus 1, the quantity squared, don't it?
Yeah.
Over sine squared theta. Yeah. See how close we are?
Close and goes.
Now, what would happen if we did this? If we took inside the bracket, we took a minus sign out, minus 1, then we could change the signs around there, couldn't we? 1 minus the cosine. Is that right? Can we do that?
Yeah, do anything we want.
I mean, I just took a minus sign out of there. Now, well, I can do it, can I?
Yeah.
Now notice, when you have a product squared, what do? You square this, and you square this. And this is 1, right?
Yeah.
I got it, right?
Yeah.
This is identical. This thing is 1 minus cosine theta squared over sine squared theta. Look where it is. Look where it is in the problem set.
Yeah.
It's at the bottom, right?
Yeah.
What do? They start out easy and get really hard, right?
Really hard.
It's an identity. Okay, does that work for you? I'll start that recording. Now, on page 215, it's going to tell you about these sum and difference identities. If you want to know how they arrive at them, you can read through that. It'd just be time consuming for us to do it, and it might be difficult for me to get it all right. But there's the identities on page 216. Yeah. It says the cosine of the sum of two angles is equal to, and that's a cosine A, cosine B, minus sine A, sine B. Now notice that when you do the cosine of the sum, it's going to be cosine, cosine with a negative, right? And then when you do the cosine of the difference of the two, it's cosine, cosine with a plus. But you will have that sheet to work with.
Nothing on the sheet.
Aren't those things on the sheet?
5.3 is on there.
5.3 isn't on that sheet.
Oh, it's on 5.4. It's on 5.4.
I did. Okay, it's still recording, so we're okay.
So 5.3 is some difference for cosine. 5.3.
There's co-functions there on, and we've done those before, right? Cosine and sine are co-functions, and so if you do the, if you do the cosine of an angle, its co-function, which is sine of 90 minus the angle. We've done all those before, right?
Where? Yeah.
On page 217,
Yeah.
we've done all that.
Yeah.
So they're just telling us
Oh,
again.
yeah, I remember that.
All right. So on page 221, page 221,
221.
well, we're ready to look at. All right. Brad,
Oh.
number 1 on 221, it says the cosine of the sum of A plus B.
You mean XY?
X plus Y. You look in your book or look at the cosine of a sum.
So it's F?
So it's F, right?
X is opposite.
Okay. So Lily, the cosine of the difference is which one? A through F. Number 2.
Number 2.
A, you're right. So number 3, Kylie? Kyla, is that what it is?
Kyle.
You know, I called a lady a name, what I thought it was her name, most of a semester, and one day everybody started laughing when I called her name, and they said, you're the only one that she'll let call for that.
I was going to say, wait, algebra last semester?
Was it algebra?
It was Reagan. You called her Regan.
Yeah.
Every semester too.
And she let me call it, and then
She never corrected you.
Yeah. Well, but only there was somebody, was she the one that would get mad if anybody else called her that?
Yeah. I would get really, really frustrated if anybody said anything.
Yeah. But I didn't know any better. She never said anything. They said, you're the only one that can call her that name.
I'm sure it was spelled R-E-G-A-N or R-E-A.
Yeah.
Reagan.
Oh,
Oh,
okay. Your name is really what? Lily Ann. Okay, I'll try to remember.
Really, we all go back.
Okay. So, is it Kyle? Kylie? Kylie, what?
Is it E?
E's right.
Yeah.
And so, Brody.
B.
All right, so that's,
You sure?
yep.
Quick, now while we're at it, please.
Where's 5 and 6?
What we're going to do is we're going to look on page 222.
222.
And here it says, use the identities to find each exact value. Do not use the calculator. So this is just for your practice. Now here's cosine of a negative 15 degrees.
Equals.
Now what you want to do is you want to say, can you write minus 15 as a sum or a difference of angles that you know? And this is what you could do. This is one thing you could do. You could say 30 degrees minus 45 degrees.
Oh, wow.
That's a minus 15, isn't it?
Yeah, Larry.
See, and then what you can do is the cosine of a difference is what?
Fine.
It's the cosine of the first angle
Yeah.
times the cosine of the second angle plus the sine of the first angle
Plus sine of A.
times the sine of the second angle.
B.
I'm just using that identity, right?
So, yeah.
So I'm just using the identity, and that's what they want you to do is each one of those things are that way, and I'm going to give you a couple of them.
So we could use like 40
Yeah.
minus 55?
Yeah.
Yeah.
Or like
If
15.
but the one thing is they'd have to be angles you know the values of.
Exactly.
30, 45, 60,
Yeah,
90.
Yeah, because you have to use the exact.
Because you have to do the exact value.
Maybe.
Don't use your calculator. So,
Right.
and they're all you're able to do it with all of them, all these. So let's just evaluate it. The cosine of 30 degrees is what?
Ah. No.
Now you know it. Unit circle. You go around it. You come to 30 first, which is what? Cosine starts out at 1 at 0, right?
Yeah. No.
What's the first one?
3 over.
Square root of 3 over 2?
Yeah, I was thinking y. I was thinking sine.
No, it's
Square root of 3 over 2.
Over 6.
it's the square root of 3 over 2, isn't it?
Yeah. Square root of 3 over 2.
And then the cosine of 45
Square root
is
of 2 over 2 is
square root of 2 over 2. The sine of 30 degrees is 1 half,
Half.
and the sine of 45 is,
Square root of 2 over 2.
see, that's what they want you to do, is figure it out in terms of values that you,
Push all those together.
yeah. So this is going to be, I multiply those two, that's the square root of 6 over 4 product,
Yeah. Plus
plus the square root of,
3 over.
this is actually a 2,
Oh, yeah, 2.
square root of 2 over 2,
Over
4.
4.
Yeah,
4.
Oh, man.
there's an echo in here. I don't know.
4.
So what we could write this as is the square root of 6 plus the square root of 2 over 4. And
Solid.
you can't, without a calculator, you can't make it any
No, I think
lower than that. So that's
you
what-
can't add square roots together, huh?
No.
So do you see, that's what you're going to do. I'm going to give you a problem that you'll have to do it that way. Now let's look at another one, which I'm going to give you one like this to do. Cosine of 7 pi over,
Can you add any square roots together into the same?
no,
Never.
no. If they're the same square root, then you can go 2 times it.
Yeah.
See, if you got the square root of 6 plus the square root of 6, then it's 2 times the square root of 6, because there's 2 of them. Cosine of 2 pi over 9 minus sine of, now, notice this. If this second angles are the same and the first angles are the same, look at your identities in reverse. Which one would this be? If you look at the right side and go left, this is going to be the cosine of A plus B, right? And then for the A, you're going to see, this is A, right? This is B, and that's B, right?
Yeah.
So this is going to be what?
7/9.
7 pi over 9. And B is going to be
2 pi over 9.
2 pi over 9. So what we have is the cosine of 9 pi over 9, which is the cosine of pi, and the cosine of pi is 180 degrees, right? 180 degrees,
0.
180
Minus
degrees.
1.
You go far enough and you'll get it, right? The
I knew it was
cosine
1, 0,
starts out-
minus 1.
cosine starts out at plus 1, right? 0 minus 1,
Yeah. X.
correct?
So,
So you're going to have
Minus 1.
all right.
These ones make sense. Do they?
Now the next ones we're going to do is 15 through 26. It says write each function value in terms of the cofunction. All right, what is that telling you you're going to be using? You're going to be using those
Minus 9.
cofunction identities on 217, right? 90 minus the angle.
oh, yeah, like,
Okay, so
Those are fun.
complementary. So let's do, and it says write each function value in terms of its cofunction of a complementary angle. It's not asking you to solve it, it's asking you to write it as that, right?
oh, that's nice. Yeah.
Okay,
Come on, guys.
so 16. So the sine of 15 degrees, what is its cofunction?
Go.
Cosine.
Yeah.
And it's what?
90 minus
90
15.
minus 15. So what you're going to do is cosine of, what is that? Is that
75.
75? See, now you can't figure it out, but all they're asking for is write this in terms of its cofunction.
Nice.
Right?
Yeah.
Let's do the easy ones fast.
Okay.
Only the easy ones fast.
18. So it's the sine of 2 pi over pi. So its cofunction is
Cosine.
cosine, and now it's 90, but 90 in terms of radians. So what's this going to be?
2 pi over 5?
90 degrees.
90 degrees in radians. What is the equivalent? No.
Oh, no.
Pi over
Pi
2 minus 2 pi over 5, right?
And pi over 2 is 90.
So now what we're going to have to do with this is we got to get a common denominator, right? So what I'm going to do, I'll do it here. I'm going to do, this is going to be 5 over 5, right? And this is going to be 2 over 2.
Yeah.
So then what I have is I have 5 pi, and then 2 times 2 pi minus 4 pi all over 10, right?
Yeah.
So this is going to be
Pi over 10.
cosine of pi over 10.
That's all further, guys.
That's the answer. That's what they're looking for. What?
You can just do this for the rest of the semester.
All right. So the rest of them are you either going to be doing radians or you're going to be doing degrees, right? And you just got to remember that when you're doing radians, it's always pi over 2.
Mhm.
And when you're doing degrees, it's going to be 90.
Pi over 2 is 90, right?
Yeah.
Yeah, let's do another one.
Yeah.
Which one do you want to do?
See one that's like more than.
27.
27 is the next set of problems.
Let's do
Let's
like
do a one. Let's do another
20.
5.
What?
Do another 5.
Okay,
Oh, that's an easy one. No, it's not.
okay, we got cosecant
It's a minor.
of a negative 14 degrees, 24 minutes. So cosecant's co-function is
You can't.
secant, and it's what, 90 minus a minus 14,
Oh, yeah, okay, so plus.
24. So this is going to be secant of, this is 24 minutes, and we're adding, right? So then it's 4, is that 104? Did I add that right?
Yeah,
Yeah.
24, over. Okay, I get that.
So that's
Yeah.
pretty easy, right?
Yeah, I like those.
All right.
Oh my gosh, Brody.
And the next set of problems says use identities to fill each blank with the appropriate trigonometric function name. 28 says the sine of 2 pi over 3 equals so
Sine of 2 pi over 3 equals.
okay, if you did cosine, if you did the cofunction, then you would do what?
Pi over 3.
You'd have to do pi over 2 minus that thing, right? Minus 2 pi over 3. Would that get us this? That's what you have to figure out. Well, don't be so quick. Common denominator, we're going to have to go 3 over 3, right? Then we'd have to do 2 over 2. So it's cosine of, and we got a 6 in the denominator, right? This is going to be 3 pi, and that's going to be what? Minus 4 pi.
Oh, yeah.
So it's going to be cosine of a negative pi over 6. So that, the answer is cosine. That's what the blank was. No, it isn't yes. The answer is cosine.
Yeah.
Fill in the blank is cosine.
Oh.
So I'm gonna just the opposite.
Okay, 30. They got a blank there. 72 degrees equals cotangent. That's pretty obvious,
Yeah.
isn't it?
Yeah.
It's tangent, right?
That's really obvious. I thought they were
They
trying
always-
to trick us on these.
Are they always
Yeah.
a co-function? or what?
It's, well, no, not necessarily.
Okay.
Yeah, because the ones right below that aren't.
Oh, no, the ones below that are different.
Like 32 then,
Isn't it? 32?
or 31.
Yeah, 31 and 32 are different.
So do you want to try them?
So 31, 32,
32. 32, I might have some more.
Yeah.
66. Well, 66 and 24 is 90, right?
Mm-hmm.
Yes. So the cotangent is 66, then 1 over is 9. So it'd be tangent.
Well, yeah,
Yeah, I mean-
it'd have to be tangent because, see, this thing would be this. Tangent of 24 degrees is equal to the cotangent of 66, but cotangent is 1 over the tangent.
Yeah. So 31 would be cosecant. I mean,
Sine.
31 would be secant 20. Is cosine 1 over secant 20 is cosine 20.
So it'd be cosine 70 is going to equal the sine of 20,
Sine of 20
and
would be 1 over cosecant.
yeah,
20.
it'd be, yeah,
Because cosecant's opposite. It only worked out on tangent and cotangent because they're both cofunctions
Yeah.
and
and
1
inverses.
overs and
Yeah.
inverses. Because the inverse of sine 20 would be cosecant.
I guess the inverse is not the right word. They're reciprocals.
Reciprocal. Okay.
All right. Okay. So the next group of problems. It says find an angle theta. Find an angle theta that makes each statement true. So we have sine, cosine of 2 theta minus 10. Now, this is the thing that's a little tricky about this. If you wrote the sine of theta in terms of its cofunction, it would be 90 minus theta. But it's saying that sine is equal to cosine of 2 theta minus 10. So these two have to be equal, right?
Right. Yes.
So 90 minus theta has to equal 2 theta minus 10.
Yeah.
And now if we move the theta over there and that over there, it's 100 equals 3 theta. So theta is going to equal 33 1/3.
Yeah. 33.
It doesn't work. Yeah.
Totally, bro.
So that's how you're going to do those, or you just take the thing, write it as the identity, the cofunction identity, and then put these two equal each other.
Yeah, if you can work that out, it's it.
Yep. It better. Stating the obvious. Okay.
I'm gonna try a harder one.
So what? Well, which one do you want to try?
One of the more numbers. I guess it's okay.
I mean, all of them, you just write it in terms of its cofunction,
Yeah.
90 minus that.
What about
Set
one that's got the stuff on both sides? Like 37 or 38.
Well, then what you could do, we could do 30. You want to do 37?
Yeah.
What 38?
I could do 38, but the answers for 37, you could practice that. 38 says cotangent of theta minus 10 degrees is equal to tangent of 2 theta plus 20 degrees. But if you use your identity, you could say this. You could say cotangent of theta minus 10 degrees equals tangent of 90 degrees minus theta minus 10, right?
Oh. Oh, yeah. So those
And
two
then
got
these
equal up?
two have to equal.
Got it.
So then you'd say, well, then 2 theta plus 20 degrees has to equal 90. Then you always do, I did this because I didn't want to lose a sign, right? Minus theta plus 10 degrees. See, it's a minus the quantity. Yeah. So I bring that theta over. So this would be 3 theta equals, and the 20 would go over here. So then what I'd do is I'd be subtracting 10 from there, right?
No.
Minus, plus,
Oh, yeah.
this would be 80. And then this would be 80 over 3.
How did you get from a 2 theta plus or minus to 90 degrees minus theta minus 7 degrees?
See this one, by definition of cofunctions, the cotangent of this angle is equal to tangent, which is its cofunction, of 90 minus this angle.
Okay.
And then I have to do minus, and I got to put a bracket so I don't lose that sign right there.
Right.
And then, so that's 90 minus theta plus 10. So I'm using those cofunction identities. It's that interesting, huh? Okay. What we'll do is we'll look at 50. These are, it says find cosine of s plus t, cosine of s minus t. 50. These are the harder ones. So what they're giving us is they're giving us the cosine of s equals a negative 8/17 and the cosine of t is a negative 3/5, and it says s and t in plot 3. So that means what? Both the sine and the cosine are negative.
Yeah.
If the cosine is this, and if we do cosine of s plus t, we're going to have know what sine is, right? We're going to have to know what sine of s is and sine of t is. So what we can do, whatever method you want to use to figure it, but if I want to figure it out using identities, then the sine, see, sine squared plus cosine squared is 1, right? And if I isolate the sine of s, it's going to equal, and it's going to be a negative, and it's the square root of 1 minus the cosine of s squared. See, what I'm doing is I'm starting with this thing. Sine squared plus cosine squared equals 1. And then I'm getting sine by itself.
Oh, I
And then I know it has to have a minus, right? Right? You see, so I'd be doing the same thing over here. I'd say the sine of t is going to equal a negative square root of 1 minus the cosine squared of t. And I'm going to have to find sine and cosine to be able to substitute into that identity, right? Because the cosine of s plus t is cosine s cosine t minus sine s sine t, right?
sure, yeah.
It's that identity, right?
Oh,
Right? And then, so what I have to do, this is the hardest part to do. So the sine is, and it's a negative square root of. And then this is going to be 1 minus, and then put that minus 8/17 squared. Now, what you want to do is you want to leave this so that you have that 17 in the denominator. So this is going to be, and I have to do this. So I'm going to have to go 17 squared is the denominator, isn't it?
Yeah.
So I'm going to have to go. No, I'll do it. It's 1 minus, and if I square 8, it's 64, right? Negative 8 squared is 64. But I have to have 17 squared up here, right?
Oh, yeah.
I'm going to have to go 17 squared over 17 squared, 17 squared. I don't want to square it out because when I do the square root, it's going to come out as 17, right?
Yeah.
But that numerator, I'm going to have to, 17 squared, I'm going to have to do it in the numerator. But see, this is going to come out to be 17. It's going to be the square root of 17 squared. That numerator is, what is that number?
No, you're subtracting, so it's 17 squared. Oh, yeah, you're right.
17.
Why does the numerator come out of the,
Yeah,
the,
does it say under the rest, or?
What is 17 squared? I know what this thing, I figured this out. It ultimately comes out to a minus 15 over 17. But it's 17 squared minus 64. Do you want me to figure it out? You guys, I thought maybe you guys had the calculator.
Oh, yeah, I get you.
289.
It stays under there.
This is
17 squared,
two-
then it turns back to 17.
289 minus 64.
Yeah, 225 is 16 squared.
Yeah,
Oh, yeah.
right.
I get it.
Yeah, this thing comes out to
Just leave
225.
the 17 because it was still squared.
Yeah, because I knew I was going to square root the denominator, right?
Yeah.
So that's why I didn't want to go 289 because I was going to square root the denominator.
Okay.
Then now you see I got these things as fractions, right?
Mhm.
And then you're going to do the same thing over here with this. You're going to go minus the square root of 1 minus, and then you substitute minus 3/5 in there.
So minus
Quantity squared. Now, this is going to be 25, right? It's going to be 25 minus 9, because when you square the 3, it's 9. And then it's all over 5 squared.
Can be 16.
No,
Yep.
25.
Yeah. Well, the only thing
Oh,
is,
yeah,
because, like Brody says, this is going to be the square root of 16 over 5 squared, and then so you're going to have a negative 4/5. Correct?
Yeah. No.
Right?
Mhm.
So now what you do is you go the cosine of s plus t is going to be cosine s cosine t minus sine s sine t. And then you just substitute those values in, right?
Yeah. That's totally rad, man.
Cosine. See, the cosine's, it's a minus 8/17 minus 3/5, right? Minus 8/17, that thing, times a minus 3/5. Then minus, and then it's these two times each other. Minus 15/17 times a minus 4/5. So the denominators are going to be the same, right? 17 times 5. And then you're going to have, this is going to be a plus, right? 24 minus,
minus 60.
okay,
So
so it's 36. Yeah, you're right.
minus 36 over.
And I guess you just have, there's nothing will reduce.
That's where we're at.
So it's 85, is that what it is?
Yep.
Yeah.
Now, you see, I'm not going to do the other part because what would it be when you do s minus t? It's the same thing, but you put a plus right there, right? Same numbers, except you're adding. Correct?
Yep.
So I can let you out 2 minutes early. I'll give you we've gotten 5-3 done.
Yeah, 5-0.